right, how's everyone doing? Good, good. All right, thanks for coming. So my name is Dave Arel. I'll tell you a little bit about myself in a sec. But what I want to talk to you guys about is accelerating your HTML5 mobile applications with the GPU, and specifically accelerated compositing. If you want to tweet about this, my Twitter handle is Dave Arel. You can say positive things or negative things. I won't be offended. So I work at a company called Belly. Belly is a startup based in Chicago. And we've been funded by a lot of really awesome VCs. Companies like Andreessen Horowitz, who I'm sure you are familiar with, Lightbank, who's the guys who started Groupon, and even companies like Cisco and 7-Eleven have invested in us because they believe in the output of us. And I know it's crazy to believe that there's startups outside of San Francisco, even life outside of San Francisco, but we like it. We really like Chicago. We think it's a really great place. It's full of really tremendous food, nice, humble people. It's easy to get around. It's really an awesome place. It's on the water. It's clean. It's beautiful. There's good hockey. I really just don't understand why people don't want to live there. I really don't understand. So Belly, what we do is, on the surface, we're a replace a buy 10 get 1 free card. So essentially, you go into the store, you you get points, and eventually you can redeem those for rewards. But in the core, we're really trying to connect merchants with their customers in a digital way. And so the iPad that we install in these stores, believe it or not, is HTML5. And we put a lot of effort into creating a really, really great, quick, responsive experience for the members that go into our stores. We've got an excellent engineering team. The whole company is built around our product. And we love cutting-edge technology as much as the next hipster. But we really like to think that we're smart about the technology that we choose. And so we really wanted to make sure that HTML5 was going to be a good choice for us. We originally went native because it just made sense. Build a native app. We only support iPad, so it didn't make we didn't have the issue of supporting Android and other platforms. But what we found was that we were deploying applications all around the country. At first, we had just opened up our second market. We're based in Chicago. We had a bunch of stores in Chicago. Then we had opened up a market in Austin. And what we found was that every time we wanted to update the application, we were having to go to the store individually, updating it ourselves, because we couldn't get in contact with somebody at the store to update it. We couldn't rely on them to do that because some of these people weren't even in the stores, the people that were responsible for that iPad. And in fact, we actually lock down the iPads so that they can't use it for other things. We own the iPad, and we want to make sure that when a member enters the store that they can see that Belly is available and ready to use. So what we were able to do is we created an HTML5 application that we could deploy to any of those iPads, whether it be an individual one, we could have a slow rollout, we could A/B test, or we could just deploy it to the entire network within minutes. So it was pretty cool. It worked out really, really well. And what I want to talk about is a little bit of what we learned. And I think one of the key things that we took out was that mastering and understanding the accelerated compositing within a browser went a long way in improving the user experience and the time, the rendering time, the performance there. So, you guys ready? Let's do this. So first, let's take a quick look at the browser's rendering process. A little high-level view, not too detailed. What would happen first is, you take the HTML, the browser would parse that, turn that into a DOM tree. We're familiar with the DOM tree, we utilize that. But then it would take those DOM elements and it would create a render tree. And it would create render objects for all of those DOM elements that created output. And the render object really knows how to style that DOM element. It knows how to style those elements. It knows the colors and the pixels, and it can render that output. But then it goes through a process of that turns into a layout tree, which determines where on the document it actually shows up in relation to all the other nodes. And then it would go through the painting process. So it would actually be, painted to a bitmap or a context. And every browser has its own sort of process, and this is just an example taken from HTML5rocks.com, which was written originally by Tali Garcia, and then modified a little bit by Paul Irish. But this is just one flow, and every browser has subtle differences. So while it's kind of nice to see those differences and understand them, it's a bit, it's a bit like that, I guess. It's frustrating, and it leads to a development style I like to call trial and mostly error, where you're just trying things until you figure out what the browser actually does. So documentation around these things aren't very strong. Chrome's been pushing to document these things, but it's still not enough. There's not enough resources for us to really see what's going on behind the scenes. When understanding the browser process, the rendering process, is understanding the CPU and the GPU within that process is the most important. And the CPU, if you're not familiar with it, it's kind of like the brains behind any computer. It does a lot of things really well, and it's a great processing unit. But it doesn't. It's kind of like a jock. It plays all the sports. It can do everything, and it's got all the right friends. But if you sit it into in an art class and ask it to draw the Mona Lisa, probably draw you a stick figure. So Mythbusters actually came up with a really interesting demonstration at a conference, which I'll show you, and it demonstrates the difference between the CPU and the GPU using paintball guns. And so this is the GPU. Sorry, this is the CPU.
3, 2, 1. Let me speed it up.
Good job, CPU. I'm so proud of you. In reality, the CPU is really great at a lot of things, and it's a powerful system. But when it comes to drawing and painting, it does things sequentially, so it's usually a little bit slower, especially when it comes to complex compositions. And in that process, we call that generally the software path, because it's just using software to do that. The page is rendered by sequentially painting those render layers from front to back. And so the render objects then paint themselves to a destination bitmap or a single graphics context. And we'll explain that a little bit in a sec. But they also created a demonstration of the GPU, which was this massive thing, which is, it's like the GPU is not exactly the most efficient thing, but it's just really good at what it does. It might use a lot of memory, but it's pretty fantastic at what it does. So this is their demonstration of the GPU.
Farming.
Okay, GPU painting demonstration.
Yep.
In 10,
9, 8,
7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over.
So it's pretty cool, not bad. GPU is pretty good at what it does. It's no CPU, but it's really good at things like painting complex compositions. Before we continue, I want to clarify though what the difference is, or at least in this context, what the difference is in painting, the term painting and the term drawing. So the painting process would be the visual representation in memory. So usually the CPU kind of draws out or paints out what that object or what that context is going to look like. But the GPU would then draw it to the display. The painting process is a lot more strenuous. You have to calculate every single pixel. The drawing happens very, very quickly. So when we talk about graphics context, that's really the composite layer. It's a composite layer, or the backing store, whatever you want to call it. It's just layers within your web app. And we often talk about hardware acceleration when it comes to animations, because we see a lot of benefit when we're applying these different backing stores to animations, because the GPU can redraw something that it knows it already has a bitmap for. It can move it around the screen or transform it very quickly, because it doesn't have to go through that whole painting process. So let's take a look at. So there's two animations going on. One is with compositing, and one is without. So there's the bottom, and there's the top. Can any of you guys actually notice the difference? Yes. So here's a little bit of a zoom. It might be a little bit harder to see it on the yeah. So the top is just kind of hopping. There we go. So top non-hardware accelerated, bottom is hardware accelerated. What's interesting though to note is that I'm animating it by using a translate 3D property and not animating the background. So the background, because it's the GPU can really only handle opacity, transforms, and filters without having to go through that whole repaint, re-upload process, which is more expensive. So if I had been animating the background, we would see a lot of repaints, and I'll show you what that would look like kind of in a second. There's been a lot of really great tools coming out. Safari, I think, actually is making a big step in the right direction with compositing, and Chrome's been sort of in the compositing, showing you the layers for a long time as well. But I'll look at both of those. But if in Safari, if you have the development tools set, you can just go to the debug menu and select show compositing borders within the drawing and composite flags. So within Safari, you'll see that there's some borders when that setting is turned on. You'll see there's borders around a bunch of things, and it's a little bit confusing. I think it's done a little bit better in Chrome, but what's nice about this is you can actually see a number in the top left corner, and that's how many times it's been repainted. So if it's composited, if you're transforming it or translating it, it's going to the GPU will handle that without having to actually repaint it. You'll also notice that like the icons in the background, there's a line right through it, and that's called a tile. So there's tiles, and I won't talk too much about it, but what tiling is basically the browser will determine whether or not if a graphics context is too large, especially if it's outside of the viewport, it won't update those tiles that don't need to be, because the texture could be huge. It could be arbitrarily large. So that's the browser's way of ensuring that they're not doing more work than it needs to. So without hardware acceleration, this is what we're seeing. We're seeing a constant repaint, and that green flashing is Chrome's paint rectangles. And so it's just telling us that it's constantly being repainted every single frame. And you can see to the right, I have 3 flags turned on. One is show paint rectangles, which is what we're seeing, the green flashingness. And then the show composited layer borders, which we don't see because compositing is turned off. And then show FPS meter, which is in the top right, showing you exactly the frame rate that you're managing for that animation. And if you zoom in, you can see, I don't know why Chrome decided to do black on blue or blue on black, but you can see it's roughly like sometimes makes its way up to 60 frames per second, which is ideal, but it sometimes drops even lower to like 8 frames per second. So that's why you get a lot of that choppiness, and this is all on the computer. So this is, with plenty of processing power. This isn't on mobile, where you have a lot less processing power. So this is with compositing turned off, much faster. You can see in the top right corner, we've got 60 frames per second consistently. The background's smooth. The little dog is smooth. That's ideal, and that's because the layers every animation has its own layer, and so the GPU is able to redraw those without having to rely on the CPU to re-upload a texture. So how do we do this? I mean, it's actually pretty simple, and most of us have probably used this already. The browsers this is kind of hacky because browsers haven't really implemented a consistent way of doing this. And unfortunately, it's just the way it is for now. I'll tell you about a spec that's being written right now. Hopefully that will come out, I don't know, hopefully not too long. But as of now, we have to rely on some hacky ways of offloading some of this work to the GPU. But generally, the browser will turn on compositing when there's something like the WebKit Transform Translate 3D property set. And as you see, it's 000. I'm not actually doing anything there. All I'm doing is telling the browser that I want to transform and translate this element, so it'll composite it for you. Chrome lists some reasons for compositing, and it can change per browser. There's not a specification around a lot of this, so browsers are just trying to come up with the best way of doing it. And for the most part, they want to do it for you, but it's not always the case. You kind of have to be smart, especially when you're working within mobile. But these are some of the reasons. I mean, mainly it's around whether or not it's a 3D or transform, some kind of translate, opacity change, or sometimes, which it's important to note that the browser will create a composite layer just because another composite layer is on top of that, and because the browser's determined that that's going to be much faster. But you could end up with composite layers that you don't expect that are actually taking up a lot of memory. And which is an important thing to note, that the GPU can use a lot of memory, so you want to use it wisely, but use it as often as you need it, because it can really help your performance. But outside of animations, there's also some really applicable ways to use compositing. For example, in the application that I built, and I'll show you a demonstration of this later, but we built a custom keyboard. The default keyboard didn't work for us because we needed it during the registration flow. And the registration flow is done by scanning a new card. And so if you scan a new card, there's no actual interaction with the web view. In Safari, I think there might be a flag you can set in hybrid apps now, but at the time we couldn't pop open the keyboard because if you tried to focus on that input, it would refuse to actually focus on that input. So we care about conversion. I mean, we need to convert as many people as we have. We have 3 million visitors, or 3 million members right now, and we wouldn't have gotten there if we had, added arbitrary steps just to sign up. Plus, we could customize it. I mean, we put at Hotmail, at Yahoo, at Gmail. We could be dynamic with that. So if you're at a college and everyone's using a .edu domain, we could actually be smart about that and then re-render the keyboard based on what the popular domains are at that area. But also note that this entire thing there's no images. It's all CSS, and probably using images would have been quicker for the browser to render, but we wanted it to be as dynamic as possible, and we used CSS, which made it harder, but with accelerating it was much, much faster. So at first what we were doing was we weren't compositing it, and we were finding that every single time we would click on one of these buttons, the whole keyboard was re-rendering. It was recalculating, repainting, re-uploading, and then redrawing. And so what we found, and at the time, we didn't really have a whole lot of resources around compositing, but what we found is that if we put, we hardware accelerated each one of those keyboard inputs, the key press, and to note that there was a key press when you clicked it, it would change the gradient color, like any iPad application would. So that process would redraw that entire keyboard. In fact, it would redraw that entire screen because there was no compositing on that screen at the time. So it was an expensive process. And what would happen is that when you clicked it, there would be a delay, like a half a second delay, long enough for you to notice it. And so when you're trying to like type kind of fast, it just doesn't feel smooth. And you can see these are actually they're two GIFs. The one on the left is the non-hardware accelerated, and the one on the right is hardware accelerated. So not only does the key presses are much faster, they're native like they're instant. It also, like when you go to the screen itself, it's much faster. You can see on the left it's actually tiling in, and that's because it's recalculating, repainting, and redrawing that entire keyboard. But on the right, we've pre-rendered that into a composite layer, and we've translated it onto the screen. So it's already been repainted. It's already been painted off into a off-screen buffer, and I'll talk about that a little bit in a sec. But and when I translate it on the screen, the GPU only has to redraw it. So Safari gives you a lot of really interesting data around this. You can see, you can inspect these composite layers. This is fairly new, and it's huge. You can go into your code base, and you can see, like I have the body highlighted right now, so it'll show me all of the composite layers within that body layer. And I can click on those, and I can see why it's being composited. I can see how many times those elements have been repainted, how many times, how much memory those are being taken up. Those are taken up, and you can actually drill down into the exact element that's being composited. Yeah, so there's so each one of those you can go through and you can see exactly what's the reason why they're being composited. And what's important to note is that not all of them are going to be composited because we told it to. The browser is going to go ahead and composite certain layers because we're animating over them or some odd reason. So it'll tell you that though. It'll tell you because it's in a certain stacking context that it's going to it's compositing. What's really interesting is when I was putting together this demonstration, I just kind of copied and pasted over some code that I had within the iPad app. And what I didn't realize was that I was using a div that I didn't need. I was wrapping the loader. And I just, I put it in. I thought that div was just kind of positioning it the way that I wanted to. Well, it turns out the browser was turning that into a composite layer, and it was 5 megabytes for something that was completely useless. I got rid of it, and it changed nothing. It just got rid of that 5 megabytes in memory. So it's really important to review all of those layers that you're using and understand exactly why you're using it, and then ensure that they're not taking up memory that you would need. Another interesting thing. So I found in our iPad application that there was these two views that were constantly being rendered, and this isn't sped up. This is real time. It's literally repainting every somewhat times a second. It was crazy, and what it ended up being was that's our custom keyboard, and that's our custom input field, because we couldn't use a normal input field because we weren't using their keyboard. And if we were using if we're not using their keyboard, a normal input field would pop open the default native keyboard, and so we had to build our own input. And so that little blinking div is a div. It's not it's just a little black box that looks like an input field. And what it was doing is I was animating the RGBA property, and since RGBA isn't every time you animate an RGBA property, it has to recalculate, repaint, re-upload, and then, or if it's on the GPU, I'll just redraw it to the screen. And because none of those were composited, nothing on there was composited except for that keyboard, the entire screen had to be repainted every single time. So you can see it was like repainting almost 3 times a second at least. So it was crazy. But the Safari tools really helped narrow that down. The other thing that we heavily use the compositing for is sort of a pseudo caching. we create these composite layers and then translate them off the screen. And I was talking about the keyboard, how we just translate it onto the screen. So all we had to do is draw it. So all those elements that you see to the right, those are actually off the screen, not displayed on the iPad display. And they're all composited layers, so and they don't change. Typically, they don't change. So all I have to do is animate it back onto the screen instead of redrawing it, or instead of recalculating it, repainting it, and then drawing it. All I had to do is redraw it to the screen. The GPU is incredibly fast at that, so there's almost no delay. So some tips around this. When you're creating composite layers, it's best to keep them small. The bigger they get, the more memory they take up, and so be cognizant of how big those are. Not to say that you can't make bigger composite layers, and that the tiling will help with that, but it's the smaller they are, the better. So if you have an updating, a div or something that updates, and you want to make sure that that update isn't going to re-render the entire page or other elements that aren't composited, you should just make sure that you're creating as small as possible. Don't go out anywhere outside of that if you don't need to, because it'll take up more memory. Composite elements that are updated often, and even if it's not being animated, if it's being updated, likely you'll get the benefit of not having to update the rest of your page or any other elements. You'll just be updating that one element. Compositing layers off the screen allows you to actually buffer and pre-render views. So I could pre-render almost an entire view off the screen, and all I have to do is translate it on the screen, which is just the draw process, which is incredibly fast. And avoid several texture uploads. So texture uploading is really when the CPU passes off a texture to the GPU to draw it to the screen. That process can be very costly. So like I said before with the animating icons in the background, if you're animating the background property, that's actually going to cause it to repaint every single time and have to re-upload to the GPU every single time. And that's a costly process, and you're probably going to lose the benefit of the GPU to begin with. So if you can translate it in some way, like the animation that we had was actually just translating it. It was using Translate 3D to move it. So that was incredibly fast, because all I had to do was redraw it. I never had to repaint it. And then really understand and use Chrome and Safari to monitor the compositing. Like I said before, and I showed you the example of there can be like scenarios where you just miss, and you're repainting constantly, or you're compositing maybe a giant layer that you don't realize, and you're taking up memory. So even though a lot of this is kind of hacky right now, there's hope for the future. There's a will change module that's in the W3 spec right now. It's a working draft. It just got put in literally last month, so it's gonna, I don't know, take a little while probably to be implemented, but look for that. That will essentially just give us the opportunity to tell the browser when something is going to change. So it'll decide to composite it because it knows that it's going to change. And we shouldn't rely 100% on the browser to do that, because we're going to update parts of our application that the browser is not even going to know about. But outside of that, the browser will be try to be smart to create composite layers when it's going to be helpful. So I'll show you a little bit of a demo of this is the iPad application that we install in Merchants, and we have a bunch of animations on the front. All these layers are composited, so it's a much quicker, smooth animation. And then I'll, in the demo, I'll go through it a little bit, use some of the features so you can see that it's pretty quick. And I definitely think it's due to the utilizing the GPU. I don't think if we turn off the compositing within our application, it's horrid. And if you really want to create a great mobile application, you really need to make use of the GPU. There's the keyboard. And I mean, that's about it. Any questions?
So you don't have to deal with like cross-browser path of field, right?
Yeah, I mean, with the application that we run, all we have to support is iPad, yeah, WebKit. Yeah.
So the way that you're enabling compositing on those layers specifically is by adding basically a useless transform.
Yeah, yeah. It's basically tricking right now the browser into thinking that that's going to animate. But hopefully that will change. Property will come out and we won't have to do that. I mean, that's basically like it's a hack until we get that.
Does it work to just, select everything?
Yeah, so if you do that, you'll likely crash your app, or because you'll run out of memory. I mean, ideally that would be awesome, but we just don't have enough memory. And like the MythBusters example, it's super clunky, the GPU, and it uses a lot of memory. It's very good at what it does, but it's not efficient when it comes to stuff like memory. So overusing it will quickly run down your application. And we've had iPads crash because we got to that tipping point. And so we had to cut back on some of the compositing that we were doing and get a little bit smarter about how we were using it.
The animations you have right there, those are all CSS3 animations? Do you do any animations with JavaScript once they're compositing?
So I mean, it's all CSS animations. I mean, I use JavaScript to manipulate it, but it's 100% CSS animations. It's all composited. Oh, sorry. So yeah, I forgot to mention that. So instead of using RGBA, all I had to do is switch to using opacity, because the GPU can handle changing the opacity without having to redraw and re-upload. Anybody else? Thanks, guys. You can follow me on Twitter and give me some feedback, or come up afterwards if you have any other questions.